Can you believe it's time to do your math again? I know, crazy, right? So we're in Module 4, Lesson 6. We're going to work with fluency with percents. And you'll notice I don't have an essential question in there right now because this lesson is basically a review of everything we have done so far. So since this is just a review, I don't feel that I need to give you an essential question that you need to be able to answer. And this opening exercise we will do in class. All right, so jump on over to page 46 if you would. All right, here we go. So on page 46, you'll see my example, and it says 75% of the students in Jessie's class are 60 inches or taller. If there are 20 students in her class, how many students are 60 inches or taller? All right, so let's see here. We are given the percent, right? We know the percent is 75%, which we can't leave that way, so we're going to change it to our decimal. And we know that they're 60 inches or taller. That really isn't important to me right now, so I'm going to jump on. If there are 20 students in the class, well, what does the 20 represent? The part or the whole? It is the whole. So 20 students in the whole class, right? I want to know how many of them are 60 inches or taller. So I am going to do this first way with the tape diagram, because I know there's a group of you who like the tape diagram, and it does kind of help me set it up and kind of give me a visualization. So I'm going to put my percentages across the top. So there's 100%, and I've got 75%, which means I want to break these into 25% every time. All right, so I'm going to break those into 25, 50, 75, and 100%, right? There is 100% of the whole class, and we know that the whole class is 20 kids, right? We know that there are 20 of them. So I could look at this and say, okay, well, there's how many sections? 1, 2, 3, 4. 4 sections, so 20 divided by 4, that means each one of these is 5. Right? Each one of those represents 5. So 5 is 25%, another 5, another 5, and another 5. So I want to know when it is 75%. So I want to know what is this point here. So I just have to add those up, and it's 15, right? Easy. For those of you who want to just use the equation, right? We have part is equal to the percent times the whole. So since I don't know the part, I'm just going to leave that. And then our percent was 0.75 times the whole, which was 20. And I grab my calculator, I type in 0.75 times 20, and I find out that the part is 15. There are 15 students 60 inches or taller. Right? They're 5 foot or taller. Okay. Let's try the next one. Bobby wants to leave a tip for her waitress equal to 15% of the bill. Okay? Bobby's bill for her lunch is $18. How much money represents 15% of the bill? Okay, so we could do this a couple different ways. This particular time, I think I'm just going to go straight to the equation though. Okay, so I've got the percent times the whole equals the part. Well, what am I given in the problem? I am told that there is a 15% tip, right? So there's my percent, 15%, but I got to change that to a decimal, so it's 0.15. And I have the bill, right? And the bill is $18. Well, that represents the whole. So I don't know the part, right? Or in this case, I should say the quantity. I'm going to cross that out. Let's change it to quantity because it's not part of this. I don't know that part. And I'm going to erase it over here, and I'll change it to quantity. Okay. Obviously, part and quantity are kind of interchangeable, at least for the equation part of it. Alrighty, let's plug these in then. So I'm going to take 0.15 times 18, and I get the quantity. All right, so when I grab my handy dandy calculator, I get $2.70. So how much money represents 15%, right? She is going to leave a $2.70 tip. All right, so if you guys notice, we have a bunch of exercises here. What I want you to do is do problems 1 and 2 I'm going to have you hit pause, and then when you're done with 1 and 2, go ahead and play. All right, so I want you to do both 1 and 2 right now. Okay, so for the first one, I had that the part was 9 hours and the whole was 3 days. So I have to change that over because I'm not working with the same unit, right? So I changed 3 days into 72 hours. However, if you wanted, you could have changed your 9 hours into a fraction of a day. I chose to do it this way. So 9 is equal to the percent times 72. When I divide both sides by 72, I got the percent to be 0.125, which then when I change it over to an actual percent becomes 12.5%. All right, now number 2, there's a little more work here. 11 a.m. to 3 a.m., right, is what his work shift is. It's a lot of time. In fact, it's 16 hours. That's the whole. His dinner break, right, not his lunch break or any of those, but his dinner break is 75% of the way through the work shift. So what time is the break, not how many hours later. So he works 16 hours, and 75% of that is when he gets to have his dinner break. So that is 12 hours. He has to work 12 hours before he can eat dinner. So he starts at 11 a.m. plus the 12 hours later, so he's going to eat dinner at 12 p.m. All right, I don't know what kind of job this guy's doing, but oof, not for me, thank you very much. Okay, take a look at the top of the next problem. Number 3, at a playoff basketball game, there were 370 fans cheering for School A and 555 fans cheering for School B. Okay, express the number of fans for School A as a percent of the number of fans for School B. All right, so what we have is that the 370 fans for School A, and we have the 555 for School B. And we want to find the percent. So our percent is unknown. Well, which one is the whole and which one is the part? In this particular case, 370 is the part. And the whole that we are comparing to is 555, right? We know School B has more fans. So let's go through and figure this out. So we have the part is equal to the percent times the whole. So part is 370. Our percent we don't know, times 555. Well, in order to find that, I have to do the opposite of multiplying by 555 and divide by 555. 370 divided by 555 actually gives me 0.6 repeating. Okay? Change that to a percent, and it's 66 2/3, or 66.6 repeating percent. All right, well, let's take a look at B. Okay, I'm going to draw a line so we keep track of where we are. Express the number of fans for School B as a percent of fans for School A. So our whole and our part have switched. So now the whole is 370 and the part is 555. And again, we don't know the percent. Okay, so we're going to set it up the same way. So part in this case is 555, and it is going to equal the percent times 370. Well, the opposite of dividing by, or multiplying by 370 is to divide by 370. Whoops, hit a button there. Divide by 370. And I find that the percent is 1.5, or 150%. Okay. What percent more fans were there for School B than for School A? So in other words, there's 100% of the people there, right? And we have 150%. So there were 50% more students at this basketball game, right? It was a basketball game, yeah, than for School B. So for every one student, or for every 3 students they had for school B, there was 2 for school A. Okay, let's take a look at what's going on number 4. I'm going to help get you guys started, and I want to see if you can figure it out. Rectangle A has a length of 8 centimeters and a width of 16 centimeters. Oh, it mentions a shape. I am going to draw it. Rectangle A, right here's A. It has a length of 8 and a width of 16. It really doesn't matter which one's length and width, whatever you want to do. Okay, rectangle B has the same area as the first one, but its length is 62.5% of the length of the first one. So they have the same area. Okay, well, let's draw this one. Let's just draw a rectangle. Doesn't matter what it looks like, really. It has a length that I don't know, right? It has the same area, though, so that's going to be helpful because I'm going to have to remember what's the formula for area. Okay? So try to remember the formula for area. Area is equal to length times width. You're going to need to find the area and then do some comparisons with those. I'm going to hit pause. I want you guys to give it a shot. This one's going to be tough, but work your way through it. Okay. All right. So there's a lot of work on this one. So I started you guys off getting you kind of started on the 2 different rectangles. I did know in the problem that the length of rectangle B was 62.5% of the width of A. So I took the 62.5, changed it over, and multiplied it by 8, which I got from here, and I got that the width was 5. Now they have the same area. I found the area of the first rectangle, which was 128, right? 8 times 16 is 128. So since they had the same area, I took that number here and I brought it into the formula for area. So 128 is equal to length, which I don't know, times width, which I found to be 5. Divide everything by 5, and I found that that new length was 25.6. So there's the answer to part A. I need that answer from part A to help me with part B. That answer now becomes the part of this new problem. And the 16, which was the length way up here at the top, became the whole of my new problem. And then I'm trying to figure out what percent this is. So I dropped it into the formula that we always use, part is equal to percent times whole. And I go through and I solve this, and I get 1.6 or 160%. Well, subtract that 100% from it. It is 60% longer. That one was really tricky. I get if you guys struggled through that one. All right, let's give number 5 a try. Okay, next page. A plant in Michaela's garden was 40 inches tall one day, and it was 4 feet tall 1 week later. By what percent did the plant's height increase over 1 week? Okay, well, I noticed a couple things in here. I noticed that this was 40 inches and then it changed to 4 feet. I've got to change and get all into all inches or all feet. I personally think changing 4 feet is easier to change over to inches. So really it's just 4 times 12, right? Because there's 12 inches in a foot. So this is 48 inches. So you're like, oh, wow, you know, how much did this grow? So how much of a difference, how many inches, if I didn't care about percent increase, if I just said, oh, the plant grew this much in a week, how many inches did it grow? Well, it went 48 minus the 40 that we started with at the beginning of the week. It grew 8 inches, right, in 1 week. Well, that is the part. And where did it begin? What are we comparing it to? We're comparing it to the whole. Okay, so we're trying to find the percent. We don't know it, but we do have everything else. So let's see here. Our part is 8, which is equal to the percent times the whole, which in this case was 40. Well, since I'm multiplying by 40, I'll just divide by 40. And I notice they're both multiples of 8, so this really reduces to the fraction of 1/5, which is 0.2, which is 20%. So my answer is it grew 20% in 1 week. It grew 20% in 1 week. Nice healthy plant. Obviously, it's not living in Mrs. Hookster's house. Plants are lucky to make it in my house. Okay, last one. Lauren must obtain a minimum number of signatures on a petition before it can be submitted. She was able to obtain 672 signatures, which is 40% more than she needs. Okay, so she has more than she needs, right? How many did she actually need? So I don't know what the whole is. That's what I'm trying to find. This represents here the whole. She has more than she needs. So 672 signatures, this is the part. And we know it's 40% more. So it's not 40%, it's 140. She got 100% and 40. So this is really 140%, which when I change to a decimal is 1.4. Okay, so plug it into our equation. We have 672 equals 1.4 times the whole. So since I'm multiplying by 1.4, I'm going to divide by 1.4. And 672, I grab my calculator, divided by 1.4, and I get 480. So she needed 480 signatures. She needed 480 signatures. Awesome. All right, so as you can tell, these are going to be all story problems, but you guys can work on it. We're going to do it in class. Don't worry. We will do well. We just got to analyze everything. I will see you guys later.